Hello and welcome to another episode of the DigiTeacher Digest. This week I'd like to continue looking at Carl Mayton's book Knowledge and Knows and some of the ideas which come out of that book, which I think are very important for ICT teachers and ICT integrators in a school. And I want to look at the whole idea of semantic density this week. So legitimation code theory refers to how knowledge is legitimated, what different knowledge codes there are. So we looked at the first dimension within LCT, or legitimation code theory, which is specialization. There is always something that is known, knowledge, and there is always someone doing the knowing, a knower. And then last week we looked at the first aspect to the dimension of semantics, gravity. How context dependent is a knowledge claim? Is it very concrete and contextualized, or is it more abstract and generalizable? This week I'd like to look at density, which is really about how condensed a knowledge claim is. Is it very simple or is it very complex? How much meaning is packed into any knowledge claim? So a quick summary. Last week we saw that in terms of semantic gravity, it can be described on a spectrum between weaker semantic gravity, more abstract, more decontextualized, where knowledge can be transferred across contexts, to stronger semantic gravity, where things are more context bound. And likewise, we can describe semantic density on a spectrum between meaning which is less condensed, is more simple, and meaning which is more condensed, more packed in, it's more complex, more meaning is contained within any word or idea or concept. So to give fancy labels to it, a spectrum between weaker semantic density and stronger semantic density. So if we talk about the metal gold, and we mean just that, denotatively just gold, metal. My uncle has a gold tooth, meaning it's been filled with gold. The meaning is quite simple. There's not a lot of other meaning and associations packed in there. In poetry, meaning is often more condensed. The Assyrian came down like a wolf on the fold, his cohorts are gleaming in purple and gold. Gold there refers not just to the dress, but also to ideas, allusions to power and wealth and majesty and imperial might. All of those ideas are packed in. And if we look at the periodic table of elements and the symbol AU standing for gold, a lot more is packed into that about its atomic number, its atomic weight, and therefore all the properties associated with gold, its whole position on the periodic table, and within a whole knowledge system of elements and how they relate to each other. And as we move along that spectrum, meaning becomes more and more condensed. More is packed in. It moves from simple to much more complex. And just as you can describe a wave from a gravity profile, so when the movement is in semantic gravity between abstract and concrete, between decontextualized and more contextualized, teachers want to see a movement between that in the understanding of their students. So an abstract idea will be unpacked using everyday language, metaphors, examples, and so on, so that students can understand it. And students need to be able to take those understandings and put them back, repack them in more academic language, and you get that semantic wave in gravity. You can also obviously have a wave in terms of the density. Generally speaking, teachers want to move from ideas which are simple and more understandable and build up a student's understanding in much more complex terms, so that students understand the nuances and complexities of an issue. And obviously then you want to move back, unpack a complex idea, and have students be able to repack it. And you get the same wave in semantic density. But another way of looking at it is to lay out those two polarities, semantic gravity and semantic density, and to lay them out in a matrix. So you get a matrix looking something like this, with a vertical and a horizontal axis. The vertical axis describes the spectrum of semantic gravity, how abstract or concrete an idea is. So at the level of abstraction, you've got SG minus, weaker semantic gravity. At the bottom, you've got stronger semantic gravity, more concrete meaning. SG+. On the horizontal axis, you've got, on the left-hand side, weaker semantic density, where ideas are more simple, and on the right, stronger semantic density, where ideas are more complex, expressed as SD- and SD+. The minuses and pluses are a carryover from the thought of Basil Bernstein. The 4 quadrants created by these axes allow one to see 4 different semantic codes. So where the semantic density is weaker and semantic gravity is stronger, meaning is more concrete and simple. Where semantic density is weaker but the semantic gravity is also weaker, meaning is more abstract but still simple. Where meaning is of stronger semantic gravity and stronger semantic density, you get meaning which is both concrete and complex. And in the top right hand quadrant, where semantic gravity is weaker but semantic density is stronger, meaning is both abstract and complex. These codes have fancy names because of course they do. So the prosaic code is both simple and concrete. The rarefied code is simple but abstract, jargon for example. The worldly code is concrete but complex. So this is the world of professional practice, for example. And the rhizomatic code is abstract and complex, the code for theory, if you like. So while semantic waves, either focused on gravity or density, give you a rough picture of what's going on in a classroom, what you can get by looking at a matrix and looking at the tours that teachers make between each of these quadrants, I think gives you a much more fine-grained and much more detailed picture of what's going on. A teacher would very rarely want to make something both abstract and more complex at the same time. I think what's really great about having this understanding is that it gives us a way of looking at how teachers unpack meaning or repack meaning within a classroom, moving between greater semantic density or greater semantic gravity, and it allows us to see the tours that are being taken. So for example, I've been doing a module on data with my grade 9 students. And we started very much in that prosaic code, simple and concrete, with creating a database table. So the relationships within a database table itself are quite simple. You have a field, it has a particular data type, and you enter data. So things are both simple and quite concrete, very contextualized. Then of course you can move on to getting useful information out of a database using database query. So queries, the meaning is much more condensed. So although it's heavily contextualized to the particular database that you've created, the meaning is more condensed. A query has, for example, sorting, and it has search criteria, and it returns results based on those relationships. So as I moved from creating a database table and a database form in lesson 1 in the prosaic code, I then toured into the worldly code by adding that level of complexity by introducing database queries and how to create a query. So that was lesson 2. And then in lesson 3, I moved on to decontextualize that. So we had remained within the context of a database itself, creating the fields, creating the data, and then using queries to search for that data. And now we moved on to create a mail merge, so that decontextualizes it, so that takes it up into the rarefied code. A mail merge is very simple. You simply link to the database and you insert merge fields from that database. It pulls information from the fields out and then will send a mail out to everyone in the database who meets the criteria of your search, basically. So in lesson 3, we were abstracting data, but it remained at a very simple level, so within that rarefied code. And I didn't do this with my grade 9 class, but you can imagine a further lesson which goes on to use data entered in a database in an interactive web browser. So users can use the web browser to enter data into the database or to take data out of the database using PHP and MySQL, for example. So you would then get a tour which looks pretty much like this, from the prosaic to the worldly code, into the rarefied code, and then into the rhizomatic code. And any particular lesson path, any learning path, could be described in this way as a series of tours through the semantic plane. Semantic gravity and semantic density, I think, offer a fantastic shorthand way of understanding how meaning is being packed and unpacked, how learning paths are being created in the classroom. And I think for an ICT integrator to have that level of understanding of what the teacher is trying to do will enable you to select the right tools and the right thinking skills to be able to help the teacher to do that. Let me give one further example. So for example, if I wanted to teach coding concepts using robotics and using block code, I could start very much in the prosaic code, giving instructions to the robot to go forward, turn right, forward, turn right, forward, turn right, forward, turn right. That's in the bottom left-hand quadrant. Everything is very heavily contextualized, and it's very simple. And those series of instructions should, if the speed is right, result in a square. I could then decide what kind of learning path I want to take the students on. Do I want to condense meaning using a loop? And you can see, visually, you can see that the meaning is more condensed here. This is at the bottom right-hand quadrant in the worldly code. I'm going to repeat 4 times going forward and turning right, and that should result in a square formation, square movement. Or I could introduce the more abstract idea of a variable. And it's more abstract because it's decontextualized. You can set a variable outside of a loop. You could set a variable in one part of a program, and then it can apply in a particular context in another part. So I'm going to set the degrees, for example, to 90 degrees, and then use that variable every time in the top left-hand quadrant. And this represents the rarefied code. I've abstracted, but it's still very simple and still very linear. Or I could combine the two in the rhizomatic code in the top right-hand corner, using a variable which is outside the loop, decontextualized from the loop, and could be used at other times in the program, and then use that within the loop itself. So meaning is both more abstract and more condensed. And being able to visualize it in this way on the matrix, I think allows a teacher to plan their instructional design and their learning path in a much more coherent way. And of course I could add further condensation by creating a function to make a square in one part of the program and then calling it up in another part of the program. Or I could add further abstraction by adding more variables which control, in the particular context of making a square, how many times the action is repeated, what degree turns are being made, and how far each move is. And of course it gives us a basic language for talking about any particular instructional design or learning path. The tours that the teacher is making here are as valid in computing as it is in history or in English or in science or in art or any subject field that you can think of. So if you're a teacher who's responsible for helping other teachers to implement ICTs or thinking skills in their teaching, then you can look at routines such as, for example, in computer science education, PRIM, predict, run, investigate, modify, and make. And if you work through these steps, I think what you'll see is that it is encouraging tours through the semantic plane. So just to look at this one, predict, you get students to look at some code and predict working in pairs or threes. They predict what they think is going to happen. They then run the code and then they investigate. They trace through the code to see where it's working and where it's going wrong. They then modify the code, either by adding complexity or abstraction. And in doing so, they end up making a new program. And using particular pedagogies in any subject, I think, helps establish what tours are being made. Are you then moving to added complexity? Are you moving towards added abstraction? What learning paths are you taking? And thinking about it this way, I think, allows you to see the kinds of thinking skills and ICT platforms that can be used to encourage them in a way which allows an ICT integrator to work across the school with a kind of common language. So whenever I look at another teacher teaching, I'm kind of sitting there thinking, okay, they're doing this now, they're doing that now, and it helps me to understand what's going on in the classroom, the overall learning path that's taking place. So we've looked at how kind of pedagogies, like PRIM, for example, can be used to help encourage these particular learning paths to happen. Well, what about ICT integration? Are there particular digital tools which can fulfill the same purpose? So last week, when I was discussing semantic waving, semantic gravity, we saw how Google Images can be used both to strengthen and weaken semantic gravity. So what is a gambrel? I search it on Google Images and I allow students to visualize what it is. They understand what it is. I've strengthened semantic gravity. But by looking at different images, both of the meat hook and the shape of the roof, it allows them to weaken semantic gravity, to abstract ideas out. And of course, digital tools can be used to weaken or strengthen semantic density as well. For example, there are a wealth of games that students can play digitally, which help to understand and develop ideas, i.e. add condensation, add complexity in chemistry or physics. So this game is all about creating covalent bonds and coming to understand the concept. So a student is being moved from simplicity towards complexity through gameplay. Or a tool like Flipgrid, for example, where students can record themselves on a phone or on a computer talking for a particular length of time. You could take a fairly complex idea, get students to work in groups on breaking down those ideas, each group perhaps looking at a different aspect, and then reporting back on Flipgrid, and then have all the students view these videos and then compile a report. Digital tools themselves can be used both for strengthening and weakening semantic density and semantic gravity. It's how you use the tool that's important. And again, there's kind of no shortcuts to that. It's all about playing with the tool, finding out what it can do, and finding out how it can fit your own purposes. But overall, thinking in terms of strengthening or weakening semantic gravity or density, making tours through the semantic plane, I think are a wonderful way of allowing a teacher in a quite clear-headed way to see what it is that they want to do. Are they trying to strengthen or weaken either semantic gravity or density at any particular moment? And then from their experience of using tools and pedagogies, cognitive tools, thinking skills, etc., what are the best tools to use for that particular purpose? The cognitive toolkit that is legitimation code theory, LCT for short, does represent something of a steep learning curve. There's a lot of language in there, a lot of ideas. But as I said right at the beginning of this journey, I think the ideas are really kind of almost self-evident. The moment you grasp what they are, they kind of make instant sense. And you think, well, of course, and it provides such a wonderful shortcut to understanding what's going on in the classroom. And I think being able to have that language which can be transferred across multiple different fields, different subjects, different contexts, gives you a really useful tool for thinking quite clearly about how to integrate ICTs in the classroom and also how to integrate cognitive thinking, cognitive education, thinking skills into the classroom as well. You can map out what it is that you want to do in quite simple terms, and then map that to different pedagogies and technologies available. It's a steep learning curve, but I hope you're enjoying the series on legitimation code theory. I want to end up next time looking at autonomy tours, which is the third dimension of legitimation code theory. If you enjoy these videos, please subscribe to the channel, like and share, please comment below, and hit the notification bell so that you make sure that you never miss an episode again.